Hello, I'm Carol Marquez, and I'm a PhD student at the Universidade Federal de Santa Catarina. Here I will present some results published in the paper Delta Baryon Neutron-Star Matter under strong magnetic fields, where we studied magnetic fields effects on neutron-star matter containing the baryon octet and also additional heavier spin 3/2 baryons, the deltas. We make use of the well-known relativistic mean-field hadronic model, RMF, that contains an additional vector-isovector self-interaction for the mesons. In this work, we consider the usual GM1 parameterization, and also the novel GM1 omega rho parameter set that has an additional vector-isovector cross-interaction fitted to improve the value obtained for the symmetry energy at saturation density. Here I show the basic formalism of the model when one is obtaining the equation of state for hadronic matter, with the modifications introduced by an external magnetic field B acting on fermions. I refer to the paper and reference within for a more detailed discussion of the procedures involved in these calculations. We are describing neutron-star matter, so we are at zero temperature and under charge neutrality and chemical equilibrium conditions. Beyond protons, neutrons, and the other spin 1/2 hyperons of the baryon octet, we included 4 spin 3/2 resonances, the deltas. In this work, we take the SU3 hyperon coupling scheme parameters and consider the delta meson coupling scheme as being given by a scaling of the attractive scalar coupling constant, the beta parameter. Here I show the particle populations when only the deltas are added to the neutron-star matter to highlight the effects of the vector-isovector cross-interaction and also the effects on the magnetic fields when there are no strangeness in the neutron-star matter. And here I show the particle populations when now the 12 baryons are considered, also varying the beta parameter of the delta coupling in this case. Now I'll show the mass radius diagrams for neutron stars for B equals 0 equation of states. Interestingly, stars that include the more all degrees of freedom are more massive than the ones that include only nucleons and hyperons, and the effects are more obvious for the case with the omega rho interaction and beta equals 1.1. This discussion is related to the well-known hyperon puzzle, but with a twist. As shown here, going for dashed lines to solid or dot dashed, the addition of deltas decreases the fractions of nucleons, some neutrons, and hyperons, lambdas, to create deltas and some protons. The overall increase in isospin asymmetry makes the equation of state stiffer when more degrees of freedom are present. So the stars are massive. That's it. Thank you for your attention.